Good day. I welcome you back on this journey with me. Welcome back and please join in to learn embedded system on ARM Cortex M4. Today is day 4. I hope you have revised day 1, 2 and 3 and you are more familiar with the ARM Cortex M4 series now. Okay, let's jump into the session to see what we have. Excuse me. Today we're going to see IDE. What is it and how to install the IDE. On learning, we're going to cover what is IDE and how IDE is going to work, and what is a linker and how it is important in the IDE, and go through the steps of installation of STM32Cube and also the 32Cube IDE options. Then we're going to chat about the debugging options in embedded code and some programming options. And this is a bit of a theoretical with practical because we're going to install the IDE. I hope and believe this will be interesting for you. So please stay tuned and let's get in and learn. Once again, for your own practice, these are all the materials you need so you can have a better practice and understand more. The more you have hands-on and practice yourself, the better you can be and acquiring the job that you are all after. So these are all the materials that's required. Please contact Pantech Solutions and they would be happy to source you all this and provide you all the help that you are after. Okay, here we go. Are you excited to learn? That's good. So let's go. What is IDE? IDE stands for Integrated Development Environment. It is a combination of compiler, assembler, linker, and loader put together in under one roof, if you like, in under one environment. So everything has got its own functionality to do its job. So that's why the IDE is really good to have everything in. And what is a compiler? A compiler is the area where you write the code on the text editor and the compiler gets that C file and it converts and gives you an assembler source code. And the assembler gets that assembler source code and then it converts to give you a object-oriented files. So then the object-oriented files is sent to the linker. The linker gets the object-oriented files, or the object files I should say, and then it gives to the linked object files, or as ELF format, and that's where it's feeding to the loader. The loader gets the ELF file and gives the last list of files, and this is the one which can be downloaded to the external memory as the hex file format. So likewise, all these four combine to do the task of programming and compiling, making it possible for us to happen so that you can fire into the target board. So that is what these four major players does in IDE. And next one down is the editor window, console window, and project window. So you will see when you get into the IDE there are different windows. So the editor window is where you will write the code, the C code. The console window is where you will see the outputs of your written code. And the project window will be the ones you going to manage about files. There will be multiple files and that's where the file management comes in, and you will do that in the project window. And there is an option to debug and release. So this particular IDE can do up to 20 options are available to do both debug and release. So what is a debug? When you compile the C code, you compile the program, you build the project, and in the debug mode, it gives you the debug information. It generates you the debug information, and that is necessary to debug the program. In case if you missed out on anything, any logic is missed out, any functionality check, if you accidentally typed the wrong word and there is a link missing, those sort of things can be analyzed in the debug, and you can fix it to be more completely bug free. So once that's done, then there is another mode called release mode. In this mode, when it is bug free completely, then it is released for production. So the production people gets this once all the error free code from the debug stage move to the release, where they get it as in a hex format, and they will still further reduce the size and make it even error free in the release option according to the production checklist. Then there is a memory window. The memory window is in this one. In this window, you see the values of both the flash memory and the SRAM memory, the data memory. The flash memory is where your main program going to sit for the boot up options, and SRAM is where all the data memory is going to stay there. And then the register window. The register window is the one where you can see all the registers that's used in your coding, and you can dig deep in and click on each and every register, and you can see the value of that registers, how it's linked, and what is the hex value of a particular register, etc. So that's really interesting when you come to the IDE and do your program. And also there is two good points in the IDE. You can set your breakpoints, meaning you can stop your program from execution, and at that point you can check the value of the register from where it's coming and how it's going. So that is a breakpoint where you can ask the compiler to stop and set a checkpoint, if you like. That's called in technical term as a breakpoint, to check the value of the variable. What is a watch point? So when you stop at the program at that point to verify a condition, you write certain conditions and to check certain conditions are met or not. So to verify that, you set a watch point. So that is a watch point to check whether that condition is met or not. Example, if a variable, if you written a variable and pass it to the variable, at that watch point you're checking whether that variable is written to that variable or not. So that is the purpose of the watch point. Debugger is a button or a tool that connects the emulator with the hardware, so that gives you options to debug to make your code bug free. In real-time analysis, you connect the IDE to the target board via the debugger option, so that's why you can analyze. And you can do debugging analysis on in terms of two perspectives. One, C++ development perspective, and the other one is in terms of further development, what it's all going to give you. So that is the IDE. The debugger perspective is once the download program to the hardware and starts to debug. That's the debug perspective. That's what it will do. Once program downloaded, after that you do certain steps, and that's the debugger does. And programming options. Some IDEs will have additional programs, options to programming microcontrollers. Some won't, so it depends on what IDE it's used. For example, on a 8051 IDE, if you use NXP semiconductors, need an additional flash programmer to load the boot program, whereas this IDE has a built-in functionality, so you don't have an external programmer to program the bootloader. So things like that. If you have a Novaton ISP programmer, it has in-circuit serial programmer. So always check with your software reference manual. Sometimes IDEs need the special connector or a special programmer. So please check with the IDE before choosing into your software needs when you sit for that software selection part of it. Now let's go through the software development flow. As you have realized or remembered from the previous sessions, the software flow is where you write a C program code, and the C program code fetches and compiles and generates an assembler source code. The assembler source code from the achiever, the macro library, generates the object files. The object file sends to the linker, and the linker is the one which generates the hex file format, and the hex file is downloaded directly to the target hardware through an emulator. So that's the software design flow, and if you go through this flow chart, you will know what exactly the development flow method is. And this is about multi-flow when you try to this is more to emphasize on the linker, how it prioritizes and how it gets the C code from various options of C, and how it can move from location to an executable file. So this is about the software development flow. I talked about linker briefly, I think on day 2. So this is where the linker I'm going to give you more explanation about. So when you work on a major project, like a complex project, the default linker will be by default connected to the external memory, just to avoid congestion on the main microcontroller memory. So it will be added to the external memory to do multiple complex things. So imagine if your processor is only 512 kilobytes of memory in there, and if you, for example, want to process a video process, and it has to do its mathematical calculations to calculate 256 times 256, which will be about 65,000 pixels it need. So your microcontroller may not be able to do that. So that's why you need an external memory where you link this microcontroller memory to the external memory. And to do that, you need a linker. So actually in the industry, there is actually a dedicated engineer who does only but write linker codes. And on this one itself, it's a really good interesting thing, because this is the one you're making the initial code to work on a larger version, if you like. So the linker is really important, where it does all its mathematical calculations, its coefficients, and anything in between in the intermediate values, where you can keep internal or external. And when the memory allocation starts changing, that's where you need the stack, where all the memory is listed, and it has the starting memory line to the ending memory line, and it's all stacked up. So just to give you an example here, in this section, every C file we have C sections. So every C program consists of different parts in your code. It's classified as a section. So all default section name begins with a dot. For example, short m, that's a .bss section. The variable that's assigned, the value that's assigned to that variable m, it has a dot extension .c in it. And likewise, when you start with the main op, so short y of 0, this is where the memory starts to happen, the stack. So anything that's declared inside main, it's a local variable. Anything which is declared outside, it is a global variable. So you can use it anywhere in the program. And then there is a set of instructions. There is a multiplication, and there is an addition. So that's where the real code sits, and that's classified as a .text extension. And then you verify the results by a printf statement, and that is standard CIO .CIO. So this will be the standard in most of the IDEs. So the linker description file is really important. Let's see how the linker description file in the memory, how it's all located. So in the external memory, when we are talking about the microcontroller will have its own internal memory, and that's linked via the linker to the external memory. This can be the DDR2, flash, whatever the case may be. It will have a starting address and an ending address, starting address and ending address. So whenever you assign some data to variables, this is all the sections where it will go and be located at. So the dot text that you see from the previous slide, it sits on flash location. The dot C in it, the global variables that will stay in the flash location. So these two must be staying outside, so they must exist after every reset. Whenever you do reset, these two will be ready to go and boot up and run. The others .bs is the global variables, and the internal variable that's inside the void main, it will all sit in the internal memory that should be in the RAM memory. So this is just to give you an idea about how and where your data move from after you compile and generate that code, and this is where the sections sit in the actual memory mapping. Then we talk about the compiler section names. So as we already know about few section names, .text is a code, .switch, .constant, .init is a global or static variables, .pin. So these all memory types that has to be initialized. So there are also uninitialized memory types. For instance, the global static variable .bss, .stack, the local variables doesn't have to be initialized. You can directly assigned to it. So that's what uninitialized means. Whereas these outside ones, you have to initialize first and then assign values. So this is about the compiler section names. Now let's see briefly about the structure of a linker file. So this is how the linker file starts with. It all sits with a linker.command cmd file, which tells you the different hardware memory locations, its length, its location, where it's going to sit, and also it will declare its software sections. So name of the memory, whether it's internal memory or an external memory, etc. So you will have both the hardware memory description and the software sections in the linker.command file. And once that's all done and linked, that's sent to the linker. So you receive the object files from the assembler, which generates and send you the object files. So the linker gets the command files and the object files, and it gives out as a dot out to send to the loader, where the loader sends the hex file format to the target board, and also the linker maps through dot map for the external memory allocations. So now we're going to see a sample of a linker command file. So if you work in bigger companies or bigger teams, the when you check with the software reference manual, so it comes with a command file. So this is how it's categorized. It will always have the .lib as a library, so it has to fetch anything from the library, and it will have stack and heap sizes. So what is the size of your stack memory and what is heap, and also the memory areas, as I was saying earlier. So it has to have a length and origin of where it's going to sit and where it's going to finish. So likewise, you have to categorize all the memory areas and the sections where you have the code and the data section. So .bss sits in the IRAM, .text sits in the DDRM, .cinit sits on the flash. So this is a sample command file. This is how it looks like. Again, in the industry, there is more specific specialist will do all this command file. Once you are familiar with the first 2 years, then you could move into writing a linker file and a command file program, which is more in-depth programming. So what are all the IDE and the compiler used in this course? So we have a target and a host, as we call in every programming, every IDE. So the target here we're going to use is the STM32Cube IDE, and the processor, the board that we're going to use is the STM32F411RE, and the host is where the IDE lives, where it sits. So the host for the IDE to run and produce and generate the output, you need the GCC compiler for desktop and laptop. So these two are the ones you need to get your IDE installed and get going. And there is a concept called cross compiler. So what is actually a cross compiler? The PC generates, the PC generates machine code on ARM code. When compiling for host, you can't simply transfer that to the ARM architecture. So for example, if your PC generates a code, it has to send to a target architecture via a programmer or IDE link. So that's what it's called as a cross compilation. So you're doing a compilation in one environment and moving to the target environment. So that is where the cross compilation process hits. And it always, when you download to the target architecture, it always goes in .hex format or .bin or .elf. But mainly it's .hex. So this is the cross compiler. There is two technical terminology that you have to understand about when you do the host machine compilation to the embedded processor, the target compilation. For the target compilation to run in the host machine, you need a GCC. GCC, it's a compiler tool. GCC stands for the GNU Compiler Collection, which is commonly known as GCC. It's a set of a compiler and a development tools available for Linux. It's not Unix, it's available for Linux, so that's what it's GCC stands for, and it's Windows based, and a wide assortment of other operating systems can also be used. And what is a MinGW? The MinGW is a minimalist of GNU. For Windows. For Windows, you need a special file to run and the compilation process to happen. So formerly it was named as MinGW32, and now they're kind as MinGW. So it is a free and open source software development environment to create Windows applications, and you can run your code into it. So this is the two files that you have to remember the name. And these both could be interview questions, so they could ask you what is a GCC and what is a MinGW, and you would be able to answer it by now. So again, the GCC stands for GNU not Unix. So it's an abbreviation from GNU. It's not an Unix, but it's an Linux. So that's what it says. This is the IDE download link that I shared with you. So please click on that link and then start to download that. It will take at least about 5 minutes, depends on your internet process speed. The size is 2.7 gigs, so please allow yourself, your computer, to have that 2.7 GB, and click on this tool and start to download. And I would like to give you a bit of a break, so please do that on the background, download this, and we'll catch up in 5 minutes time, and I'll go through with you the setup of IDE. Thank you. I'll see you again in 5 minutes.